James is actually the director of life panels, which I'm sure he'll go into a little bit more detail of what that actually constitutes of, wood fiber panels. But James also has a long history in the realm of construction and carpentry, and as he's been introduced to lots of various materials in Europe, he came across wood fiberboard and showcasing a fantastic material to be able to improve the performance of many various homes and larger scale buildings. So he's actually bringing that technology over to Australia. James also is recently a certified passive house tradesman. So a lot of what he's trying to do, not only as a product supplier for life panels, he's also trying to do a lot of things in the realm of educating the industry around how can you detail and use products, low embodied carbon products, to create fantastic outcomes. So if you could please join me in welcoming James, and James, will let you do the rest.
Okay, hello everybody, good evening. Yeah, so why am I even doing this as a job, and why am I interested in it? I want to start at the very beginning, the big picture. Obviously, at the moment, it's easy to think of everything in black and white terms, that it's this, it's that, it's right, it's wrong, that's a better detail for a wall, that's a better detail for a wall. There's a lot of conversation and frustrations around that. And for me, what I always go back to as a master carpenter is, when you get given the skills, you're able to see that it's not quite black and white. It's very grey, and you've got to look quite close to see the detail. So that's really a good challenge to say, you know, how are we going to think about buildings that we build? Innovation and connection. Is it okay to view innovation in isolation, to look at it on its own? With buildings, I'd like to encourage us tonight to think about going back before we even select the very materials that we use to build with, or the very materials and the technologies that we use to heat or cool the buildings, to think back to even before that stage, which is about moisture, how moisture behaves, and the materials and the technologies that we choose, how they affect that moisture behavior, because that's a given. And then heat and cold energy as well. And so the rest of the presentation will drill a little bit into that. So yeah, so innovation and connection, what does that even mean? Hopefully that's getting a bit of a laugh. It's difficult to, it usually gets a good laugh. But what we've got to have is innovation and connection together, because then you're going to get better and balanced outcomes. So some context to explain that. Ken's already suggested about the connection across Australia. Where I am right now, our warehouse is on Kookinburra country, and I wanted to share this picture with you. I don't know if anyone's seen 10 Canoes. It's a brilliant movie, you should watch it. In this picture, it shows obviously young fellas in a canoe, but the particular part of this movie that I want to talk about is something that's so great for us to learn from. So they get to this body of water and they stand on the shore of the water, and they obviously need to get across and be on the water. So from a Western mindset, most of us would adopt an approach of, we look up and down the edge of the water, we go, okay, there's some timber, there's some twines, let's just make a canoe, no problem. But in the movie, what they do is they say the phrase, the best timber for a canoe is nowhere near water. Say that again. The best timber for a canoe is nowhere near water. And then they turn around and they head back inland. And then it shows the process they go through to make the canoe. Now, they've got the best canoe, the best material, the most efficient, it's the least destructive, the least intrusive into that delicate ecosystem at the water's edge and the mangroves. So that's why I want to say to you tonight, I like to raise this conversation around thinking about not just the innovation of, we've got a problem with damp, great, we've got a dehumidifier, we've got a problem with overheating, great, we've got some air conditioning. Because when you view those innovations in isolation and as just a one-stop bolt-on methodology, for me, that's why we're in the problems that we're in. But I'm incredibly impressed by the human ingenuity. Human was so incredible at creating amazing technologies and solving problems. And then we realized that this technology created this problem, but now we can do this to tweak that and make it better. So that's one of the brilliant things that I just find immensely impressive about our human being race. But at the same time, we do sometimes operate with this stupidity in mind, where we just forget to remember that sometimes the solution that we need to apply to the buildings that we're building and the materials that we're choosing may not be the immediate appeared solution. Wolfgang Feist created the first passive house, I suppose, principles and developed that. And this is crucial for me in the space that I'm in with insulation, which is the fabric first. So we've got to learn to be better at building. I want to just show this quite technical, but some credentials that I always advocate for anybody. Don't take my word for this. This is something that you can find from most material suppliers. And it's these top 4 criteria: the density of the material, and the higher the better. Low thermal conductivity, the lower the better. And most insulations will have that particular component, as you'd expect. But it's the other 3 either side of that that are really crucial for understanding and working with moisture behavior and heat and cold. And we'll come on to that later on. But specific heat storage, the higher the better, and vapor diffusion resistance, the higher the better. The decrement delay, as you can see on that particular line item, is 3.8 hours, and that's on a 60 millimeter thick product versus the synthetic, which is a 90 millimeter thick product. So you can see why there's a difference there, and wood fibre is a great performer. So a bit of experience and knowledge. As mentioned, I've served my time in the UK as a master carpenter, a licensed builder in New South Wales, ran my own building company in the UK, where researched healthy building materials and really questioned why we were doing what we were doing. Why are we using these materials that they seem good on paper, but then you use them and they're difficult to detail, they're awkward to cut, they're itchy, loads of practicalities that you don't get from the classroom environment. So the passive house, as most of you probably know, it helps look at those components of a building: the insulation, the low thermal bridging, the air tightness, ventilation, the windows and the doors. But what it doesn't do is then use a technology like Woofy, which is an analysis software that will look at the temperature, the relative humidity and the moisture content within that proposed build-up that you can model in the PHPP. And that will tell you, if you use these materials, you're going to get damp and interstitial condensation at this point in the building. And at these times of the year, it's more risky or less risky, et cetera, et cetera. So again, it's back to being, it's not quite black and white. We've got to really understand what we're looking at and why we're choosing to look at it. So bit of an intro to the building physics. The big three are the thermal performance, the moisture control, and the overheating control. So why would you choose wood fibre to look at some of these? Bit of a case study. A lot of this data is available on our website and materials. So if you do want to catch up with me later on, we can chat about that and over the coming weeks. This case study was a full wood fibre house, fully vapor permeable. And the case study is pretty interesting with some both positives and then there's a design review section that highlights the weaker points of the building and how to address that. So low thermal bridging, you basically just think of it dropping a tea cozy over your house to reduce, and the phrase I use is low thermal bridging rather than thermal bridge free. Again, because it's not necessarily black and white. So low thermal bridging is basically the concept of wrapping your building to reduce those thermal bridges. A continuous wrap of insulation is the best way to do that. And bearing in mind, when you do that, you need to have one of those 4 criteria, which was high vapor diffusion. Airtightness, most people are fairly aware of this at the moment. Vapor permeable membranes, and essentially reducing the leakage of that warm or cool air from inside your building to help maintain a more stable with less fluctuations. So that's quite a crucial one. Breathability. You obviously need to be allowing moisture and vapor to pass through the building. Now, this is a big one, particularly amongst builders who kind of think we've got to keep the moisture out, keep the moisture out, keep the moisture out. Okay, so don't have a shower, don't have a party, don't breathe. So we have to use materials that are highly vapor permeable. Relative humidity. This is a bit more of a complex one, so I won't go too deep into it. But essentially achieving somewhere between 40 to 60% relative humidity with an ambient indoor temperature between 20 to 25 is going to be how we achieve optimal comfort and healthy air quality. Thermal mass. Now, this is a really hot topic at the moment and some good discussions around it. So wood fibre is perfect for thermal mass. Now, before you think, what are you talking about, man? Concrete. Okay, so thermal mass is a conversation that we can have on another time, and feel free to contact me directly about this. But for thermal mass to work truly efficiently and in balance with all of the other building physics components and with those 4 criteria we talked around at the beginning, it isn't black and white, and it has to be considered in the design, the orientation of the building, the relative humidity levels, the WUFI analysis, and elements of the passive house design. So it really is quite complex. But wood fibre is great for basically buffering the heat and keeping that heat in with the air tightness. So it's part of a system. It's not just a standalone product. And that also ties in with the decrement delay, which you saw on the credentials chart. So we want to slow that process down. And to do that efficiently, we need high heat storage capacity of a material with very low thermal conductivity of a material. So in summary, the most cost-effective way to use as little energy on a house as possible is a fabric first approach. Then to slow the heat loss in the winter, we're going to use materials with very low thermal conductivity as a building wrap, along with the air tightness system. And to slow the heat gain in the summer, we're going to use materials with a high, that should actually say heat storage capacity, and low thermal conductivity. Now, this is a big one that often people overlook. So this would be a great area where people go, we just need to insulate the house. It's black and white. We've got poorly insulated buildings, insulate. But the unintended consequence of that is that you essentially make the building more sealed. So you create more problems with damp and mold if you don't understand the physics and behavior of moisture, heat energy, and cold energy. So that's why, again, it has to be part of a process and a well-designed, thought-through model. And then the wood fibre, on another level, is fully renewable. It locks up CO2, and it's fairly quick and easy to install. Pretty much done, I reckon. So if you wouldn't mind, it'd be great, because it really helps me and the company with our opportunities. Also helps me with feedback to say what wasn't so great about the talk, what was good, what was interesting, what you'd like to see more of in the future and at future presentations. So I'd love it if you'd take just a few seconds to scan that QR code on your phones, and then just put the review title as ASBN Spotlight, so we can just track where the feedback comes from. And then, yeah, just leave a few comments, and that would be very much appreciated. And look forward to your questions. Hopefully that was in 10 minutes, Ken.
Thank you so much, James. I'm also trying to not be totally technology defunct, but yeah, thanks heaps for that explanation. We'll put you on mute live here, but really appreciate the rundown of building physics, because it's a lot of us need a lot of those reminders of what we actually need to accomplish from just the basics of that. So thank you very much for that, and then also kind of alluding toward that procurement or the specification of the right kind of materials can help really drive down the embodied energy of what we create as well. So thanks heaps for that.